Atmosphere and climate. Most of Earth's weather occurs in the troposphere, the part of the atmosphere that is closest to Earth's surface. In the activity The Causes of Climate, you learned that the ocean has currents that move warm and cold water from one place to another. The troposphere has currents as well. Similar to the oceans, atmospheric currents move air and the thermal energy it contains from one place to another. The patterns of the currents in the oceans and atmosphere are major factors that help determine regional climates. Guiding question: what role does the atmosphere play in weather and climate? Earth's atmosphere. As you learned in the activity Local History of Severe Weather, the atmosphere is the mixture of gases or air that surrounds planet Earth. Compared with Earth's radius, 3,952 miles, the atmosphere is very thin, about 186 miles. There are 5 distinct layers within the atmosphere that are defined by temperature change with altitude. See the table below. Take some time to look at this table. Notice that it lists Earth's atmospheric layers. This table gives the atmosphere as 5 layers: the exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere. The main gases in dry air are nitrogen, 78.1%, oxygen, 20.9%, and argon, 0.9%. Carbon dioxide is the most common gas in the remaining 0.1%. The percentages of these gases remain the same within all 5 layers. Water vapor is not included in dry air percentages. Unlike the other gases, water vapor concentration varies from 0 to 4% of the atmosphere depending on where and when you take the measurement. Notice that the exosphere is about 120 kilometers or more above Earth's surface. In the exosphere, Earth's atmosphere merges into space. Notice that the thermosphere is 80 to 120 kilometers above Earth's surface. In the thermosphere, the space shuttle orbits the Earth. Notice that the mesosphere is 50 to 80 kilometers above the Earth's surface. In the mesosphere, meteors usually burn up. Notice that the stratosphere is 12 to 50 kilometers above Earth's surface, and in the stratosphere, ozone layer absorbs some of the sun's harmful ultraviolet radiation before it strikes Earth's surface. Notice that the troposphere is 0 to 12 kilometers. In the troposphere, most weather occurs. The troposphere is also the cruising altitude of most commercial aircraft. Wind and weather. Weather occurs in the layer closest to Earth called the troposphere. Because the troposphere is heated from the ground up, the temperature tends to decrease as the altitude increases. The materials on Earth's surface, e.g., rocks, water, plants, absorb some of the sun's energy and heat up. These materials then heat up the air in the lower troposphere. Since some of Earth's surface heat up faster than others, different areas have different temperatures. Warmer, lower density air rises, creating an area of lower pressure air below it. Differences in air pressure are a driving force of weather and weather systems. Take a moment to study this graphic. It's titled Atmospheric Layers and Temperature. Notice that the top line gives temperatures in degrees Celsius. And notice that the lines are dotted differently. One line indicates temperature, the other line indicates approximate boundary between layers in the atmosphere. Notice that as you get higher up in the troposphere, the temperature decreases. Notice that as you get higher up in the stratosphere, the temperature actually increases. And as you get higher in the mesosphere, the temperature decreases a lot. And then as you get higher in the thermosphere, the temperature starts to increase. The temperature seems to follow a zigzag pattern as you travel up through the layers of the atmosphere. Wind is the movement of air. Wind blows leaves off trees, pushes clouds across the sky, and moves water and thermal energy around the world. Air moves when there is a difference in air pressure. Wind blows from areas of higher pressure towards areas of lower pressure. When there is very little or no difference between pressure in two neighboring regions, the air is calm and there is little or no wind. When there is a lot of difference in air pressure between two neighboring regions, strong winds can occur. In general, wind speeds tend to be higher in the daytime when sunlight can heat Earth materials and create greater differences in air temperature and pressure. The fastest wind speed recorded as of 2017 is 318 miles per hour during a 1999 tornado in Oklahoma. Take a moment to look at this graphic of different types of clouds. Clouds are described by their height in the atmosphere and their shape. Thermal energy is spread through the troposphere because air moves and contains water vapor. Air near Earth's surface absorbs water vapor, and as moist air rises in the atmosphere, the water vapor begins to condense. As water vapor condenses, it releases thermal energy and forms clouds. On average, clouds cover 40 to 50% of Earth at any given time. Clouds are carried through the atmosphere by wind. Weather is strongly affected by how stable or unstable the atmosphere is. Stable air is air that is not moving vertically very much or at all. With stable air, it may rain or snow or it may be sunny, but the weather will not be severe or change quickly. Unstable air moves vertically, which can cause the weather to change quickly with very little warning. The more unstable the atmosphere is, the more likely you are to see clouds and experience storms or even more severe weather, such as tornadoes. Atmosphere and climate. The way Earth's atmosphere interacts with the sun's energy and the oceans helps determine Earth's average temperatures and its different climate zones. Because areas nearest the equator receive the most direct sunlight, air around the equator is typically warmer than air at other latitudes. Similar to the oceans, air heated at the equator moves north and south towards the poles, and this circulation affects climates in all regions. If Earth weren't rotating, there would be only two cells that circulated air, one between each pole and the equator. However, due to the Coriolis force caused by Earth's rotation, the direction of air and water currents bend, creating six cells, three north of the equator and three south of the equator. You found evidence of the existence of these cells in the activity worldwide wind. Reread this paragraph as you look at this graphic. Notice that we have the northern hemisphere and the southern hemisphere. The northern and the southern hemispheres are separated by the equator. Notice it says if Earth weren't rotating, there would be only two cells that circulated air, one between each pole and the equator. However, due to the Coriolis force caused by Earth's rotation, the direction of air and water currents bend, creating six cells, three north of the equator and three south of the equator. Count the cells. The caption says, Earth's rotation toward the east causes air currents to bend to the right in the northern hemisphere and to the left in the southern hemisphere. This is the Coriolis effect. Remember, this is also seen with hurricanes. Hurricanes spin counterclockwise in the northern hemisphere. As well as helping move moisture and thermal energy around, the atmosphere affects global climate in another important manner. Some of the sun's energy that strikes Earth radiates back from Earth's surface and will be lost to space if there were no atmosphere. Some surfaces on Earth, such as ice, reflect a lot of the sun's energy back into space. Other surfaces, such as concrete and asphalt, absorb the sun's energy and radiate thermal energy, warming the atmosphere. Some clouds reflect sunlight back into space and cool the planet, while other clouds act more like a blanket and warm it. There are gases in the air that absorb and hold thermal energy that would otherwise escape from Earth. This is called the greenhouse effect, and the gases are called greenhouse gases. By trapping some of this radiated energy, the atmosphere helps create and maintain the different climates on Earth. Natural processes such as respiration, digestion, and volcanic eruptions add such greenhouse gases as water vapor, methane, and carbon dioxide to the atmosphere. There are also natural processes that remove greenhouse gases, keeping things in balance. Living organisms play a key role in keeping the atmosphere and thus Earth's climate stable. Almost all living organisms require gases in the atmosphere for essential life processes. Plants, for instance, require carbon dioxide and produce oxygen. Both plants and animals require oxygen and produce carbon dioxide. The cycling of gases between different organisms and the atmosphere helps maintain an environment that supports life and keeps the chemistry of the atmosphere relatively steady. However, a change in the amount of greenhouse gases in the atmosphere can disturb this balance and affect climates around the world.